Swayam Prabha. Digital India. Educated India.
The story listening is a dangerous thing. Okay, after listening to the story, you should have some questions to ask. That only it means you are thinking. Otherwise, how will I distinguish whether you are sleeping, opening your eyes, or you are really listening? How do I know? If you are not asking question, I conclude you are all sleeping, opening your eyes. No question? In that very same hall, few days ago, I taught for +2 students, +1 students. Like you, they collect bright students and they bring here and they did some 15 days training. They were asking questions after question. I have to run away like that. When +1 students are asking so much question, you are college students. Right? So don't hesitate. See, you miss, then you miss forever. So ask question, whatever simple it may be, silly it may be, no problem, ask. No? No question? No hesitation, start. I will ask you first, ask question. You have to ask some question. And then I will ask him. Be ready. You have no question? Here. Right, I told no. You should sit in the front bench. Very good, 2 seats are vacant. Next time you sit there. But you also have to ask. You should be the first one to ask question. Thermochemistry? We did no. We did the Born-Haber cycle, converted into voltage. We took a chemical kinetics, rate of the reaction, converted into current density. We discussed spontaneous, non-spontaneous in terms of galvanic electrolytic cell. That's how you connect. You have to draw parallel. What you learnt there, it may be called with a different name here, different terminology here. You have to understand these two terminologies are same. Thermochemistry we call like that, when electrochemistry we call like this. It's the same thing. Right? No, it's like I go to temple, you go to church. Both are same because the purpose of going there is same, right? It's not different. So you should understand. But here I recite some mantra, there are different mantra I recite. But you still do the same thing. Correct? No? Any other question? For example, we linked the force, how the force develops, so the electron moves across the interface. So we linked all the way to Newton's law. So no difference. So whatever you study in physics, you stay here. Correct or not? So energy difference, I link it to velocity, then to momentum, then energy. Physics coming to chemistry. That's what I am repeatedly telling you. You have to get into the habit of linking the subject and understanding it. As long as you don't do it, you will not understand the subject. If you are not doing that, it is a waste of time. Niyanan or some the Tamila function last week, did you see? 8th standard teacher, what question the other side asked? What is the question? Anybody see? What is the program you see? If you can tell me. What programs you watch in general? All program, no? Tamila you watch? Yes. Niyanana you watch? Last week what happened? What was the question? He asked old teachers, new teachers. That was a debate. This guy asked question to that side. That teacher is teaching up to 8th standard. The question is this: if the diagonal of a square is root 2 times A. What is the side of the square? She said, I don't know, sir. Immediately I cannot tell you, sir. This is a teacher. What is the side? You know? But this is teaching for 8th standard kids. Finally, it goes somewhere discussion. Everywhere, finally they come into the discussion of how to handle the emotional. That's all different. School means subject also important, no? That first we have to discuss. Right, no? So, I am not blaming, but the point is how we are preparing our future generation, how we are recruiting, everything important. If the wrong procedure we follow, wrong teachers only will come. Then what they will teach? KAT, CAT they will teach. Right, no? Right or no? Any question? You don't have time, we have to go to the next topic. Only one question so far? Boys did not ask any question. I asked you, now you would have prepared. What is the question? You thought I went that side, I will not come this side. See, the purpose of bringing you here is to invoke thinking in your mind. If you are still reserved, it is very difficult. I am not loser, you are the loser. Why did you come here when so many students are there? They did not come. Why you came? Ask question, no? Ask. Right? Okay, I will ask question, you give answer. That's all. Nothing I can do. Because you are not asking question. Right? No? Shall I ask question? Suppose I am making a cell. It's a zinc copper cell. Zinc copper cell. So I pass 1 ampere current. Pass 1 ampere current for 1 hour. Or let us put it like that. 1 ampere current for 26.8 hours. How many hours? So when I am saying this, you have to note down. Don't write it like a sentence. Write 1 ampere, 1A, comma. So input parameters are 1A, comma, right? 26.8 hours. So 26.8 H, comma, right? What is the cell? Zinc copper cell. So write zinc / copper cell, correct? And I am charging the cell now. Charging the cell. Okay. Now tell me how much zinc is reacted, how much copper has reacted. How much zinc has reacted, how much copper has reacted. For this question, 2 minutes time. I am going to ask answer from you first. So go. Zinc copper cell, 1 ampere current, 26.8 hour. So how much zinc reacted in grams or in moles? You can put it in moles if you want. How much copper reacted in moles? 1 mole? 1 mole? You are close to that, but not right. Why not right? You have to think. We are charging, right? So charging, zinc is reduced, copper is oxidized. Correct or not? Okay. Then how much zinc is produced? I asked zinc reacted. That means includes zinc ion, copper ion. So you are telling zinc is forming, copper is dissolving, right? Copper becoming copper 2 plus, zinc 2 plus becoming zinc. That's a reaction. Then tell me how much zinc is reacted, how much copper reacted. 2 mole. How? But what is the charge? 1 ampere 26.8 hour. Total charge is how much? 1 ampere into 26.8 hour. Total charge is how much? 26 point? 26.8 ampere hour. How many moles of electron? 2 mole electron? 1 mole electron. If 1 mole electron goes to zinc, how many moles of zinc will form? What's your name? That also you don't know? Niveda. Iveta. Tell me, if 1 moles of electron goes to zinc, how many moles zinc will form? Write the reaction. Zinc 2 plus zinc 2 plus how many electron? Right, 2 electron gives you zinc. State of the matter. Yes, the other side. Aqueous, not solid. Zinc 2 plus solid, aqueous solution, right? So 1 mole of zinc to produce you need 2 moles of electron. But how much moles I gave electron? 1 mole only. Then you divide that equation by 2. Then what will be the left side? Half zinc 2 plus, correct? Then 1 electron gives you half zinc, correct? Then only the equation 1 moles of electron coming. So how many moles zinc? How many moles of copper will react? 5 moles, because that is also copper 2 plus. So 0.5 moles of copper ion will be added into the solution. At the same time, 0.5 moles of zinc 2 plus ion will be removed from the solution in the form of zinc metal. Correct? No? Yes or no? See, I don't like this story, no? விடிய கதை கேட்டுட்டு காலையில் ஸ்ரீஜைக்கு ராமன் அந்த மாதிரி பண்ணக்கூடாது, ரைட்? One more, you see how difficult. It's a very simple problem. You are struggling. You have to start writing. Correct? Now tell me, what is the energy density or what is the energy that is produced from this cell? Energy that is produced from this cell. I have all the record information here in the standard condition. For zinc electrode here, copper electrode here. What is the energy produced? How will you calculate? Write. Whatever you want, you write and show me. First of all, you decide, are you going to do it like a galvanic cell or electrolytic cell? Whatever I given was electrolytic cell. So, but you assume it is now a galvanic cell. Okay? You are forming a galvanic cell. That means which is your anode? Zinc, because that is more negative. So, your cathode is copper. So, assume it is now a galvanic cell. Now, calculate how much energy it give. 1.5 what unit? 1.1. Why hesitation? Tell me. Electron volta. What is the unit it is given? What is the unit? E cell is equal to E cathode minus E anode. E cathode is 0.34. E anode is minus 0.76. So minus of minus 0.76. So total becomes 1.1 volt. இங்க என்ன யூனிட் இருக்கோ அதான வரணும். But I want energy. How will you get energy? What you get energy? Energy. What is the relation which relates energy to the voltage? I have given you an equation which relates energy to the voltage. Which is that equation? What is that equation? Del G equal to, Right. Del G equal to minus NFE, substitute. How much it is coming? What is the N there? Is that a reaction? Correct? What is F? What? N? How much is N? Okay, why it is 2? What is the question I asked? How much energy it is giving? Energy density also fine. How much energy density I asked or energy? Energy I asked. How much energy it is giving the cell? Yeah, but to get the energy you need N, no? How much? Okay, let's put it very simple. You have a two-wheeler. You put 1 liter petrol. How much distance it goes? Say 50 kilometers. Now you are putting 2 liter petrol. Every condition same way of riding, everything same. How much distance it will go? How? Double of energy is there because double of petrol is used now. So energy is proportional to how much petrol you took. So in this question also, when I ask you how much energy produced, it should be proportional to number of. It will be proportional to number of electron is always for 1 mole of zinc, 1 mole of 2 moles of electron is always fixed. Correct? No. Now here energy you get depends on what? How much zinc you reacted or how much copper and zinc you reacted. Correct? No. So your answer to my question is you should ask me question. Tell me how much zinc you reacted. That's a question you should ask me. You cannot say N is 2, N is 4, N is 10. Because you see, the same equation I write it differently. Then you tell me what is N. So I am not writing the state of the matter for convenience, but you don't do that. What is the number of electron? 4 now. Correct? No. So the number of electron it depends on how you write equation. So I calculate energy now. I will put here 4. I can put here 1. I can put here 3. I can put here 10 also. Doesn't matter. But if I do that, if I put here 2, what it means is indirectly I have reacted only 1 mole of zinc. Because 1 mole of zinc will give 2 electron, right? So if I put N as 2, it means I have reacted only 1 mole of zinc. If I put N as 4, 2 moles of zinc. Then delta G will be double that of previous value. It makes sense. 1 liter petrol, 2 liter petrol, you get double the distance. Same should be true here, right? So that N comes from the way you write equation. It is not a fixed value. Who told you for zinc it should be always 2? I never told you to do that way. I only asked how much energy produced. For that you should know how much zinc you reacted. Then only I know how much energy I produce. So that n depends on that. So this delta G is for the reaction. Delta G reaction. If this reaction is this, n is 2 because here I used 2. If the reaction is this, n is 4 because I reacted 2 moles of zinc. And in that case, in this case, double the energy I will get from there. So delta G here is an extrinsic property. Volt here, I mean E cell here, is an intrinsic property. What is extrinsic? What is intrinsic? Extrinsic depends on the quantity you take. You take 1 liter petrol or 10 liter petrol, accordingly energy output will vary. That is extrinsic. It depends on the quantity you take. Intrinsic depends on the condition. I take 1 mole zinc or 2 mole zinc, but still my conditions are same 1 atmosphere pressure, same 25 degrees centigrade, solution is still 1 molar copper sulfate, 1 molar zinc solution, so the condition is same. So the voltage will not change because you took 2 moles of zinc, voltage will not double. Still the voltage, as long as you maintain the condition same, the battery you make this big or this big, same voltage only will come. But what only change when you increase the battery size? Amount of material inside changes, that is zinc or copper. Therefore, energy delivered by the big battery is more than small battery. So the energy that you get out of the battery is an extrinsic property which depends on the size of the battery or weight of the battery. But the voltage is specific to that condition, which is an intrinsic property, that does not change. The n value only changed, therefore delta G changed, not V value or the E value, E cell value did not change. Am I right? Clear? So you might have studied in thermochemistry also extrinsic property, intrinsic property, right? Delta G bar extrinsic or intrinsic? What is delta G bar? What is delta G bar? Bar, no. Delta G bar. What is delta G bar? It's okay. Chemical potential, right? What does that bar means? Napa? What does that bar mean? CP bar. What is CP bar? CP na heat capacity at constant pressure, CP. Bar means? It's called specific heat capacity. When I say specific, I indirectly specify I am taking only 1 mole. That means I am assuming 1 mole zinc only taken or 1 mole of some gas is taken. Similarly, whenever I put a bar, I indirectly tell you I know the quantity I have taken. Therefore, I divide by that quantity, I get it so much energy per gram, so much energy per mole, some normalizing factor. So, I get some value here and here, correct? Here also N is 4, F E cell, correct? There delta G is minus 2 F E cell, am I right? If I wanted to know what is delta G bar, here this bar means I have taken 1 mole of zinc. Then what I should take? I take this value divided by, see this is for 1 mole of zinc. This energy came from how many moles of zinc? So, this gives this. So, here it is delta G, but I can call it as delta G bar if I want. But if I put a bar, I should tell what is that in the denominator. Is it 1 mole of zinc in the denominator, or I mean moles of zinc in the denominator? Because when I say bar for a reaction, it is very confusing. Why? I can express it for 1 mole of zinc or I can express it for 1 molar copper also. They are stoichiometrically related, but I can. Some of the reactions are not straightforward like this. For example, H2 plus half O2 gives water. Here it is not, if this is 1 mole, this is not 1 mole. This is half a mole. Here in this case it happens these two are 1 mole. Correct, no? So for this reaction, if I want to know delta G bar, I should tell what this bar means here. Is it per mole of hydrogen or per mole of oxygen? If I say it is per mole of oxygen, it is twice that of per mole of hydrogen. Correct? If I say it is per mole of oxygen, that is equivalent to twice that of delta G for the same reaction per mole of hydrogen. Interconvert. So when I put bar, I should tell which material I am referring to in that equation. And if I say that, then you can. So this is called specific quantity. Specific means you divide by a number. You are making it per gram or per mole, right, or per liter. That's specific. You remember in the battery calculation, we discussed specific capacity. Why? So much milliampere hour per gram of the lithium. That's why it's called specific capacity, because I normalized it per gram of the lithium. If I don't tell, simply I give you a battery and ask you what is the capacity. I cannot tell until unless I know how much lithium is inside. If I know, then yes, I have 10 moles of lithium, then I know 1 mole of lithium can give this much, for 10 mole of lithium this will give so much. I can tell you this is the energy or this is the capacity inside the battery. Correct, no? Makes sense? Any question? Clear? So the delta G we write is delta G reaction. If I put a bar, then in the reaction, which one you are taking at reference? Is it hydrogen 1 mole or oxygen 1 mole that you are taking reference? Then you will know. Okay? I can also say this, if it is delta G bar oxygen is equal to 2 times of delta G of reaction, correct? Because this is a reaction I am considering. If I am taking it as 1 mole of oxygen, then I have to multiply by 2, then reaction energy I multiply by 2. Correct, no? Clear? Yes, of course it is a chemical potential, because chemical potential if we see it is delta G divided by N. N is the number of moles. So it is per mole. That is why it is chemical potential. It is the same thing. Correct, no? Clear? Right? Now we will go to battery chemistry. So I will go up to 6:30, then we stop. Although you are interested, I am interested, but you are tired also. So I have to stop. Now you got the basics of what is charge, what is current, how current related to rate of the reaction, what you mean by spontaneous, non-spontaneous, electrochemically, galvanic, electrolytic, how a concentration cell can be a galvanic or can be an electrolytic depending upon the situation, how we did some calculation also based on those things, right? And in that process we understood what is intrinsic property, extrinsic property, correct? Now with that knowledge, let us go to the battery chemistry. So in the battery, there is one battery which everybody use, that is a lithium ion battery. So already we have discussed about the zinc copper battery and lithium hydrogen battery, magnesium hydrogen battery. So many batteries we have discussed. Now I am going to lithium ion battery because this involves some solid state chemistry. I thought that knowledge of solid state chemistry you have can be used here. Have you studied solid state chemistry? How do you study solid state chemistry? There is some sphere here, 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 like that you study, no? There is of no use, right? You have to apply which solid material we are discussing and why we are studying its structure. That is very important. That is why you have to link the subject, right? No? Now let us look at it. You know the graphite has got a honeycomb lattice. Okay, this is honeycomb lattice. You see honeycomb, honey is there, no? Its nest, like that it will look like. So now you see there is one layer here, there is one layer here. They are not one above the other. They are slightly shifted. So now the third layer will come. The third layer will be exactly above this layer. And fourth layer will come, it will be exactly above this layer. So if we have such a pattern, we call it as a, correct? It also we call this hexagonal close packing, correct? But this is not hexagonal close packing strictly speaking, the sense It's not a triangular lattice, it's honeycomb lattice, is missing one atom in the middle. We will come to that later. So largely it is hexagonal. So now if you look at it, this metal was used as a host for the lithium, and later on it is called as anode material for lithium battery, and this is invented by Professor Akiro from Meiji University in Japan. He was one of the Nobel laureates who shared the Nobel Prize for battery, you know. Who are the other two gentlemen? Who are the other two gentlemen who got Nobel Prize along with him for lithium ion battery? What do you do in school, college? You will go, come, that's all. You have to have some data knowledge, you know. Who are the other two fellows? Newspaper, what you look for every day, tell me. What is the news you like in the newspaper? Kola, kolla. This is the news you are looking for every day in newspaper. What is that you are looking for? Right? Professor John Goodenough. Other one is Professor Stanley Whittingham. These are the three guys. Correct? No? Very good. Now let us look at this. This is given because when you take a metal and when you plate the metal, when zinc is getting plated or when lithium getting plated, that means when you reduce lithium ion, it becomes lithium. So it's called plating. We assume that it will plate uniformly everywhere. But what if it is not plating uniformly? Instead, it is growing like a tall building. Okay, it's possible, right? Zinc only grow in one point and grow like that. We call that as a dendrites. If dendrites growth happens, instead of uniformly plating, in one place it is concentrating and growing like a needle, and that needle will go touch the other electrode. If that touches, it's called shorting. Then battery will not work. Okay, to avoid that issue, he has given this material. In this material, lithium can be stored nicely as a lithium ion. Therefore, this is he got a Nobel Prize. So that the dendrite growth is avoided, lithium ion battery become a reality. So we have the battery in our cell phone. Even then it catches sometimes a fire. If such advancement not there, it is impossible to use the battery. Concept will be there, but device won't be there. Now let us look at it. Now I am adding lithium ion to this, adding one electron. This is a half cell reaction. So this lithium will go between these two layers and the electron will go to this layer because this has got a cycling electrons, right? This is all sp2 carbon, right? So it has cycling electron. So it is go to that, electron will be added to the layer and the lithium ion will go between the layer, and this structure will look like this. These green ones are lithium ion. Okay. So now you see this is a B type of stacking. Once you put lithium inside, okay, these layers will move slightly. That means this will go exactly above this. Then what will happen? It will become A type of packing. But in between the A, we have lithium. These are the lithiums. You see here, correct? So now let us do this, because you have done in a FCC unit cell. Okay, how many atoms are there? In FCC unit cell, how many atoms are there? 4, correct? How 4? How 4? How 4? Corner 1/8. Face 1/8. How many face is there? So 1 plus 3 is 4, correct? Corner 1/8, 8 corner, 8 into 1/8 is 1, correct? So now that's how 4 atoms comes for the FCC unit cell. Am I right? Suppose if an atom is in the edge center, what is the sharing? From the top view, I look at a square. So you know, you can have a cube like this, right? If I look at the top view, it will look like this, correct? Correct? So this is a corner which is here. Corner atom shared by 1 by in 3D. Edge center? How 4? 2 below, 2 above. There will be 2 cubes here. Face? Correct? If something inside the cube, all clear? Keep that in mind. Now I have drawn a unit cell here. Tell me, this is lithium, this is carbon. How many carbon is there? How many lithium is there? Quick. You know everything, no? So now you tell me, this is a unit cell. That grey line I have put is a unit cell. The green one is lithium. The brown one is carbon. Tell me how many carbon is there in the unit cell? How many lithium is there? You have to do, not look at me. How many? ஏதோ கால்குலேஷன் பண்ணாதான்ப்பா வரும். How many edges are there? எட்ஜில் எத்தனை இருக்கு? 8 8 64 8 edges இருக்கு. நான் edges எத்தனை இருக்குன்னு கேட்கல. How many atoms are in the edge? No. Without doing this division, you tell me prima facie looking like that, how many are there? Then we will come to the sharing. How many are there? Count பண்ணுங்க. 1 same way here, correct? 16. What is the sharing? 1 by 4. So 16 into 1 by 4? 4. How many face center? How much? 6. வேற எங்கேயாவது ஆட்டம் இருக்கா? வேற எங்கேயும் ஆட்டம் கிடையாது இல்லையா? This is a top layer, this is a bottom layer, there is no layer in between, so no atoms. So 6 carbon, correct? Now lithium. How many lithium? They are in the edge center. So
1 by 4 into 4.
how much? 1. So how many lithium? How many carbon?
1 lithium and 6 carbon.
LiC6. Okay. So this is a unit cell of lithiated graphite. Lithiated graphite because lithium is introduced into that. And how many? What is the formula of this? LiC6. So that means every 6 carbon can take 1 lithium. That is how our anode metal is in the lithium ion battery. Okay. Now you will see the 3D animation of that, how it will look. Clear how it looks? If you connect 3 neighboring lithium, what is the shape you get? Triangle. Okay. So if you get triangle when you connect 3 nearby atoms, it's called triangular lattice in 2D. Triangular lattice. And if you connect for carbon neighboring one, if you connect, what is the shape you get? hexagon. So that's a honeycomb lattice. Imagine இந்த கார்பன்ல சப்போஸ் நடுவுல ஒரு கார்பன் இருந்திருந்தா அது என்ன லாட்டிஸா மாறி இருக்கும்? இந்த ஹெக்ஸாகோன்ல நடுவுல ஒரு கார்பன் இருந்திருந்தா what is the lattice it would have become? Triangular. Correct, no? It's very simple. You take a hexagon, your dot putting na, you can divide into triangles. How many triangles make one hexagon? 6 triangles. So lithium forms a triangular lattice, carbon is in the honeycomb lattice. Now you see in the lithium ion battery, when the lithium comes, it will go between the graphite layers and get stored there. If you put too much lithium, the layer will go because it cannot accommodate so much lithium. That's called exfoliation. We should not do that. That's why we are putting 1 lithium for every 6 carbon, not more than that. There are more intricate things which I am not discussing because it's not needed for you. You are not a research student. Clear? Huh? This is lithium, no?
Yes.
Around that there is a yellow color. What is it? What it could be? You take how lithium ion battery is made. One side you have a graphite electrode, other side you have a cathode. In between electrolyte. What electrolyte will have? Electrons. Electrolyte? No, liquid electrolyte only will take. The liquid electrolyte, what will be there? For electrolyte to conduct, what it should have? Electrolyte to conduct panamna, it should have ions should be there. So you will take a lithium hexafluorophosphate LiPF6, dissolve it in the electrolyte, in the solvent. That becomes electrolyte. A solvent plus salt becomes electrolyte. That is nothing but solution. A solvent plus solute gives you solution. So a solvent from a salt gives you electrolyte. Then electrolyte must be a solution. Yes, it is solution. In the context of electrochemistry, we don't call solution, we call electrolyte. You see the difference? What you call solution, we call electrolyte. So that lithium ion should be there in the electrolyte. Then only it will go intercalate into the electrode. When some salt dissolves in a solvent, how it dissolves? Because compared to lattice energy, the hydration energy is more or solvation energy is more. That's why that bond breaks, ions goes into the solution. That's why sodium chloride, when you put it in water, goes into solution. Because the lattice energy of sodium chloride vida hydration energy better. So therefore it goes into the solution. Correct? No? So this layer around it is a solvation cell. You take sodium chloride, put it in water. It is disintegrating, disappearing. Same sodium chloride, you put it in kerosene. Is it dissolving? Then that is also liquid. This is also liquid. Why? Only in water it is disappearing. So how will you explain? I am holding someone's hand. Someone is pulling me. Will I go with them or I will be with him? That depends on. That depends how strong he pulls. You pull so strongly than this bond, then I will go. If he pulls very weak compared to this bond, I will stay. Same. In sodium chloride, there is an interaction between the sodium and chloride. So there is a lattice. So lattice energy is there. Okay. Compared to that, if water ion interaction energy is more, then sodium will say bye bye to chloride, go with the water. Right? No. So the solvation energy is much higher compared to lattice energy. Therefore sodium chloride dissolve. Whereas in kerosene or in some organic liquid, when you add sodium chloride, it is not dissolving because that interaction is not that strong. Okay. Who is giving that interaction? That is different. In case of water, there is a lone pair of electron which is interacting with the sodium. Therefore sodium goes with water. That's called ion dipole interaction. Yeah, that's the origin we will look at later. But that energy balance only decides. It is not that sodium chloride likes water, therefore it went inside. It's only the energetics. Energy is everything, correct? I go to a job, somebody gives 10,000 rupees, some 20,000 rupees. If a job profile both are good, then where will I go? Same. There is a driving force, no? Like that here also there is a driving force. So once that ion attached to the water molecules or a solvent molecule, that I am showing it as a shell. That's all. Okay. Now come to this cubic closed packed structure. It's also called FCC, face centered cubic lattice. Am I right? Let's look at it. What kind of lattice is that red one? Triangular lattice. Yellow one? How are they different? Their positions are different. Now what about this color one? Triangular lattice. How is it different? Its position is different. How its position is different? This one is now at this position. So that means if this is A layer, this is B layer, then if you put atom here, that is C layer. Then next one will be A layer. That means that will be just above this. That's how you describe the FCC lattice, face centered cubic lattice, right? So basically I have shown the FCC lattice. Now I am going to connect to some atoms and then I am getting a nice face centered cube from here, right? That I have taken out and I am looking from the top, then you will have atoms like this, one atom in the center. And do you see this? You see all are same color in this direction, in this direction, in this direction, correct? Because I have taken this atom connected to this and made it, yeah. Therefore, along this diagonal you see only yellow atoms, that is here, right? After that this will become a diagonal of another cube. So then this comes, alternatively they come, correct, no? Now I am going to draw this structure again here. What I have done, the corner atoms I made it small, face center atoms I made it big. There is a reason. If I connect all the face center atoms and I make a closed object, closed 3D object, what is the shape of that object? Hexagon is 3D, yeah? Hexagon is 3D? What is the shape? See, this shape is fitting inside the cube. How this can be cube? Say something better. Take this, connect this, connect this, connect this, connect this. What is the 2D shape you get? There is one above, one below. You get octahedron. So it's an octahedron. What is inside the octahedron? Nothing. Void. We call it as void. Now, where else octahedron is coming? If I take these two atoms, that means this small atom is here, and this face atom and this face atom is here, and two atoms from the neighboring unit cell. Then where is the octahedral void is coming now? Which position? Corner. Oh, it will be in the center of this, right? Similarly, here center comes where? Here, right? Edge center. So you get it in the edge center. But edge center contributes how much to that cube? 1/4. How many edge centers are there? How many edge centers are there? 12. So 12 into 1/4. How much? And 1 is inside. Total? So 4 octahedral voids belong to this unit cell. How many atoms are there in this unit cell? Calculate. You are all lazy fellows, I tell you. 4. So 4 atoms makes a unit cell. It will create 4 octahedral voids. Can I say that now? Because that also 4. Octahedral voids also came out to be 4. Then if 4 atoms make 4. So if n atoms make a lattice, n octahedral voids will be there. N. Okay. So now let us concentrate here. This atom, this atom, this atom, these 3 here, and 1 corner atom I am taking. If I connect these 4 atoms, what is the 3D shape I get? Tetrahedron. Right now? How many such tetrahedron I can do? How many such tetrahedron I will do? 8. Because 8 corner are there. In 8 different direction I can make a tetrahedra. Correct? One facing this direction, one facing this direction, this. Correct? Look at this. Carefully look at this. 1, 2, 3. These 3 atoms, you look at it. They are face center atoms. Correct? That is the same as 1, 2, 3. That means these 3 atoms are common for the octahedra and tetrahedra. If 3 atoms you connect, what is the shape you get? That means this octahedra and tetrahedra are sharing a face, a triangular face. Correct or not? Can I say that? Okay. Now you look at this animation. This is octahedra, and you see the triangular faces. Tetrahedra will build on that. Then finally the shape will look like this. Where is octahedra? It is inside these tetrahedras. So inside each tetrahedra we have a void, which is tetrahedra void. Inside this entire thing there is a void, which is octahedra void. Clear? Any doubt? Now we will go to the complicated things. Now imagine you have a void here, no? I am going to put one atom there. That atom will be different than this atom. Atom here you assume it is chloride. Atom already there is chloride. The atom I am going to put is sodium. Okay. If I put sodium here, automatically where and all I have to put sodium? All the? Where are the octahedra? Where are the other octahedras are there? Inside each cube. Other than that, so if I throw one sodium here, I have to throw here, I have to throw here, I have to throw here, throw here, throw here, throw here, throw here. Correct? So I will have 8 Na plus going to, no, 12 Na plus going to edge center. That means 3. 12 into 1 by 4 is 3. And 1 Na plus going to the body center, belong to the whole is that. So 3 plus 1, 4. But earlier you estimated, if this is chloride, earlier you estimated 4 chlorides are there. Now 4 sodiums are there. If I put sodium in the octahedra void, then what is the formula now? 4 NaCl. 4 NaCl is equal to NaCl. That's a formula unit. Clear, no?
Swayam Prabha. Digital India. Educated India.